Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's easy to get started with the next generation of deployment and scaling, powered by the battle-tested Linode platform, including simple pricing, node balancers, 40 gigabit networking, and dedicated CPU and GPU instances. And now you can launch a managed MySQL, Postgres, or Mongo database cluster in minutes to keep your critical data safe with automated backups and failover. Go to pythonpodcast.com/Linode today to get a $100 credit to try out their new database service, and don't forget to thank them for their continued support of this show. Your host, as usual, is Tobias Macey, and today I'm interviewing Jonathon Wright about the role of automation in your testing and QA strategies. So, Jonathon, can you start by introducing yourself?
Well, it's a pleasure to be here. Yes, I'm Jonathon Wright, based out in Oxford in the UK. I've been in the automation landscape for the last 4 decades, sometimes referred to as the automation cyborg sent back in time to save the world from bad software. So I'm looking forward to talking to the Python community as well, especially around automation, machine learning, and everything that you need to know about, how to get better quality in testing.
And do you remember how you first got introduced to Python?
Well, many, many years ago, I must admit it came in when people started tinkering, I suppose, with data science as kind of a discipline. And of course, Python, I've been looking at Haskell, which, is a maths-based programming language, which is what I've been playing with at the moment because, you find that you're switching between them. But the majority of my developers write everything in Python. But I don't know if you've had any experience with category theory. It's a bit of a pain on the brain, should we say.
Yeah, it's definitely interesting digging into more elaborate type systems and formal functional programming, and especially when you start getting into even more complex and esoteric languages like Idris and starting to think about, okay, how can I make sure that everything that I write is provably correct?
Absolutely. I kind of joke with one of my developers about the fact that obviously Klingon's loosely based on maths as well. So, should we, start moving away from English language and start writing in Klingon to avoid ambiguity? But it's maybe not the fastest growing language, whereas obviously Python, everyone, especially as the data science community just keeps on growing, and also the automation community, there's just so many people using Python today. I think it's only going to get bigger.
Absolutely. Or Esperanto, which was constructed as a language to remove ambiguity, and nobody ever really caught on with it, at least not wide enough for it to be notable.
Yeah, my friend Tom Gilb wrote a language called Plangwidge back in 1985. It was part of something which he published his first book on, called Evo, which was evolutional development, which is long before the Agile Manifesto. And he created Plangwidge with this kind of viewpoint of how do I get rid of that ambiguity. And it was really interesting. I'll make sure in the show notes I share, because we have something called Guild Fest where everyone meets together every year to think about what's coming next down the software train. And he shares all of his documentation in a big Dropbox folder and all of his notes and what he's learned over the years. So, that hopefully that'll be interesting. But, my friend Paul Gerard, he had a project recently in Lisp, and, that he was asked to do Lisp in DevOps and also then in the cloud. And it was just kind of those, obviously predating COBOL as a language, but it's coming back into fashion. It's amazing how these things happen.
Absolutely. And the main focus of our conversation today is around kind of QA and validation and testing for software. I'm wondering if you can share a bit about sort of how you ended up working in that space and why it's something that you're spending your time and energy on.
Yeah, definitely. So I must admit, I came out as a computer systems, high performance computing grad, and I was doing things like Occam, which was distributed parallel processing languages, and then got a gig working my first job straight out of university at Siemens. Siemens was Siemens Engineering, and they were such a engineering based organization that they actually got me involved in doing automation, which was very interesting. When I took the job and they said to me testing, I genuinely thought that it was going to be picking phones up and putting them down and making sure they worked. And then I found myself with an Abacus, which was a binary-based system to program PABXs. And then I started my automation career kind of the early kind of 90s when, these systems were just getting built. And then we were doing things like voice over IP testing of silent suppression stuff. It was really quite interesting. And of course, a lot of the other people who I was working with, all graduates in computer kind of studies and programmers and developers, as well as testers, of course.
In terms of the overall concept of kind of QA and testing and automation, there are definitely a lot of different rabbit holes that you can go down. And I'm wondering if you can maybe share kind of the high level view of what are the commonalities, regardless of what specific area you're focused on, and what are maybe sort of the main categories of how companies and software teams think about and work towards addressing the testing and validation and QA aspect of their work.
Yeah, software is infinitely complex, as we know. And, we do have this tendency of trying to apply manufacturing processes like Lean and Kanban to something which is software, which is, you can't apply those same kind of methodologies, so we say. And so testing phases over the time, we could joke about the fact of saying, well, what came first, the test or the code, and of course, with modern day principles there, such as TDD, test-driven development, BDD, behavior-driven development, and ATDD, acceptance test-driven development. There's that kind of movement towards, building the test first and then creating the code to make it pass. I must admit, this time, probably 3 or 4 years ago, I was sat with Dan North, who, was kind of one of the grandfathers, should we say, of behavior-driven development. And he kind of had seen where kind of these kind of Gherkin-based executable specifications had gone the direction of, things like given, when, then as a way of trying to define incredibly complex systems, which, again, in natural language, which had ambiguity in there. And of course, from a DSL perspective, it was really focused on trying to make it as human readable as possible for the business with this kind of, well, let's get the three amigos involved and, developers and testers, which should all be working in harmony. Whereas we really know that's not what the real world's like. And as the pace of software development increases and we go from DevOps to kind of this continuous delivery kind of cycle of, pushing and going straight to production is, this ability to do testing and the differentiation between checking and testing, which I guess is kind of when you start looking at things like integration testing and unit testing, component testing and static code analysis. We really focus on, building a certain amount of confidence or how we would want to test the system. Whereas then when it goes into the real world, a bit like the House of Dragon bringing down, HBO streaming services, this is much more complex. There's chaos engineering, site reliability principles that maybe aren't always, looked at. I noticed the other day, Amazon have now got a fault injection service, which they've got to purposely try and bring down your Kafka or whatever else you're doing, so that you can actually try, put those gremlins. And I did a podcast with a guy called Colton, who actually was responsible for doing chaos engineering at Amazon. It was he runs a company called Gremlin, with Gremlin in the software kind of thing, is how do you find those bugs and how do you find those pieces of malicious software or software that's not optimized that could potentially bring down those pods or however you've created that infrastructure as code. And, I think there's so many layers now that, I genuinely can't even think of a place to start or a place to finish. But I think the only one rule that probably rules to rule them all is that wherever there is a line of code, there should be an associated test, whether it is infrastructure as code, configuration as code. You need to build that in early and you need to feel confident that it's got that level of quality built in from day one. And it's not an afterthought that once we've got it MVP, we'll come back and get it over, the code coverage over a certain percentage. I bored a whole stack of students for a full day of code coverage for testers. And it was generally the most boring subject I could ever think of. But, it was that subjective thing of, well, what is it meaningless if it's less than 100%? Again, testing is incredibly subjective. There's so many different camps for it. And of course, now there's this shift towards software developers and tests to get people involved earlier. So lots of things to unravel.
Yeah, as you said, every layer of the stack has its own, accompanying complexity. And as with everything in software, you can solve it with another layer of indirection. You just need to add that level of abstraction. So I can say, I only need to test from here up or from here down or this layer in the middle. And then, that brings you to integration tests where no, you have to test all the way through and figuring out what are the happy paths and, when is good enough, to your point of code coverage or kind of chaos engineering. Another interesting aspect of the overall question of kind of testing and quality assurance is who is responsible for it, where early in the life cycle of software engineering as a discipline, it was very common for you to have kind of the waterfall approach of, design, build, test, release. And the testing part was usually its own department where the software engineers would write the code and then they would hand it off to the QA department and say, good luck, go see if it breaks. And then if it broke, well, then you have another long loop. And, with the adoption of things like DevOps practices and the whole idea of shift left, testing has become more the responsibility of the developers, and maybe it goes into the design stage too. It starts to permeate all of the aspects. And I'm wondering how you have seen the distribution of responsibility affect the overall concepts of kind of quality assurance. Like, are there things that we've lost in that process?
Yeah, I think you are right. Kind of the shift from the traditional V model and requirements engineering, which is why, I referred to Tom Gill originally, but, his first book was Requirements Engineering with a guy called Eric Simmons. And it was all these dimensions of how you could look at, documentation inspection. My friend Dorothy Graham, who is the grandmother of automation, she allegedly wrote the first line of code in 1965 for Bell Labs. And, she published a book called Software Inspection. And, part of it is there's some disciplines we've lost from that kind of, I guess you saw the word there of engineering at the end of the term. Quality engineering, of course, being an emerging kind of area over kind of quality assurance. And then you raised the infinite challenge, which was, quality is everyone's responsibility. But by saying that statement, does that mean that no one's responsible for quality? And this is what we've been trying to do, especially at Keysight. We've been talking about things like quality stream management, very similar to value stream management, of tiers of, a team can be delivering a widget or some kind of integration point or node, should we call it in the simplest of terms. So who's responsible for the quality? Is the coder? Is it the team? Does that change as the teams adopt new methodologies and decide that they want to do Spotify models and squads because it sounds fantastic? Or, they don't have SRE engineers sat there. They don't have release train engineers for scale agile or less or DAD methodologies. They kind of can choose where the buck stops as far as, is the quality, a C-suite, how do we realize that we should spend more money or spend more time before releasing a product out to market? So, understanding that, I think, is infinitely impossible from a quality perspective. So that quality lifecycle management, from the idealization of coming up with a concept that sounds like a great idea to the proving of the hypothesis, which could be minutes, hours, years, is a time factor based on lots of different methodologies, and I did a fantastic podcast with a guy called Niall Lynch, who unfortunately passed away during COVID. But, he created something called time to quality, which was, the time for us having a perceived understanding that the software is up to a certain point to then understand the technical debt and the challenges with the pattern. We think of an app ops kind of approach. We're going to use this particular distributed pattern. There's some kind of issues. By the time we've got something stable and the quality is up to a level which our end customers wanting, if it's a commodity platform versus an investment banking versus a retail versus a kind of a disruptor, which is just trying to get their tech in the space very quick. So, part of it is these are all different paces. And this shift left movement has really moved into shift right. And this is kind of what I've been talking about for probably the last 5-10 years is how do we prove that on the right-hand side and learn from the right-hand side to feed back in. And I did a TED talk on cognitive learning, and that was that feedback cycle from, what's happening in the real world and how do we measure and learn from that? So we see, how do we know Salesforce today is at a certain level of quality, and the next release doesn't break that and then potentially break hundreds of organizations that use Salesforce as their critical kind of platform. We have no way, nothing stopping anybody releasing software. And so therefore, kind of our, CEO did this big pitch around, this quality certification for hardware, why is there not that in software, right? Anyone's allowed to release software or break software. How do we potentially get to that point where this kind of equivalent of a CE kind of tag to say, if you do business with this, let's say DoD military contractor who's writing software, it needs to be a certain level. Equally, for instance, for the DoD modernization bill, they're actually talking about a bill of software quants in essence, which is then saying it's made with Log4j. I'm building it on Neo4j for my graph database. I'm doing, this particular type of technology, which I'm utilizing. And if there's a vulnerability on that, it understands which part of the software needs patching or even bringing down. We, of course, heard, Apple announcing the vulnerability from a third party, analyst that found this kind of root access to all devices, again, which we've had before. It's that same kind of cycle of, well, how do we deal with, these situations which could be security related? It could be systemic failure of systems breaking because of the reliance on, their two-factor authentication servers, or maybe their Cloudflare kind of built up DNS, or the structure they've used on a particular cloud vendor and this multi-cloud kind of landscape. There's so much complexity there. And the buck doesn't really stop with anyone, apart from usually the operational team who are hitting it first end. And then again, they're dealing with a different incident management and a service management platform to the developers are. The loopbacks, feedbacks of, okay, well, here's the digital twin of the system working in production. Now reproduce that within a kind of a TiVo kind of way in development, which typically are, devs are working in container in K8 kind of instances on their machine. Maybe they don't have access to that production data, those production scenarios, those real kind of environments. So learning a lot more about what we do in the real world and the real world's configuration and how it actually responds in the wild, it helps us to inform on how we build better software. And I think that's definitely some of the big trends that I've seen is there's a lot more focus on, as you're probably aware, of observability, and bringing in things like open telemetry with kind of an open tracing kind of replacement, and then looking at how do we take this information to give us better pinpoint failure analysis, root cause analysis, much quicker with, more accuracy. And, you see a few of these vendors that are doing, code debugging in production. It's getting to that point now where I think we need to be honest with ourselves. And we're building software on a house of cards. How do we, ensure that those poor IT directors or, software development directors manage to live more than 5 years in their job without some catastrophic failure or, having to hide all those skeletons in the closet? Can we get a grade on, whether or not we're using a grade A website or a grade C website? And, there's a good chance that it's going to fail, or if it's built to last and it's robust and secure and reliable.
I particularly like the house of cards metaphor because the way you keep it together is with duct tape, clearly, and that's what we all end up doing.
It is. Things like ops dev, building for ops instead of building for dev is kind of that kind of landscape of, you look at this beautiful pattern and then you look at the 40-year-old organization that you're trying to deploy it into, and they just don't have the operational skills to be able to deal with these, complex architectures. And they're also mixing it. It's like you can look at a company and kind of guess what architecture it's built its foundational systems on by the year it was born. And you kind of see the refreshers coming through that logically do. But, some of those organizations are just not prepared for the next gen kind of architectures. And then, don't even start mentioning about, building on AI-based systems. You suddenly get a massive challenge, right? That you've got, this kind of, unpredictable kind of nature of, how is your algo, doing in the real world, and how is it doing it today versus how it does in 6 weeks' time, and whether or not it's giving people insurance payouts for the things that you don't want. It's even more difficult for the next gen platforms that people are building today.
Another interesting thing that I'd like to dig into before we get too far into the automation piece is the kind of Venn diagram of the terms quality and testing, because a lot of software teams will focus very heavily on testing and say, okay, I wrote this piece of functionality. I'm going to write some tests to make sure it does the thing that it's supposed to do and doesn't break under the circumstances that I can predict. Or maybe they're even using property-based testing so that it can throw in some inputs and scenarios that you can't necessarily think of off the top of your head. But in a lot of the description that you were just giving, you focused on this term quality. And I'm wondering if you can maybe give some clarity on the ways that those two terms are being used and some of the ways that the focus and the terminology influences the way that the approach to software kind of build and delivery is done.
Yeah, I think it's a great question. And, I'd like to kind of think that quality and testing exists, but never shall the two meet. Every time I speak to someone, quality means something completely different to testing. And, a quality assurance team responsibilities are completely different to a traditional testing team. And, just like we do with every mashup, whether it be product management and engineering to create product engineering as Google did, we're similar seeing this with quality engineering is how do we bring quality in and engineering into the same teams, have quality engineers in there in the same way we have test engineers as we have data engineers. We're really trying to bake that engineering back into it. But the responsibilities are completely different. Quality is very holistic. It's very much about the overall process. In a way you could say, I'm going to do an audit of your company's processes, whether it's your CI/CD process or how you do your static code analysis or your secure coding workshops. You'd be looking at holistically everything, whereas testing, you might be saying, I'm testing this one component. You could be testing it in functional or non-functional testing. API, you could be doing stubs and shims. You could be using service virtualization. You could be using network virtualization. You could be using packed and contract testing. There's lots of different viewpoints of it. Of course, that's why we always find system integration usually fails when we all start coming together and we've all used different practices and techniques to that point. And we've kind of said, it works in our environment and then move it across. Now, I know that's the aged-old kind of problem of trying to say, well, we throw it over into a different environment and it doesn't build. But of course, we know we've learned a lot more from continuous integration and testing and DevOps, which had that philosophy of if it hurts, do more of it. And now we've got to that point where we're terraforming, we're building things up, we're blowing them away, and we can execute all the tests and then delete them. We can spin up entire performance environments with, terabytes with the databases, with, mass subsetted, obfuscated data sets, synthetically generated if they need to be. That's realistic enough to be able to run those high volumes on, private, cloud tenanted environments, have that level of realism. So we've definitely matured and we've got this whole kind of lots of different phases that we can do. I guess the question is, where as an engineer should I be spending most of my time, right? Again, there's lots of different ways of approaching this from an automation perspective. Automations seems to be the easiest word to throw around. I did a Forest reply to a new quadrant we're doing at the moment called Automation Fabric. And it sounded really excited when I, opened up the term thinking, it's going to be like data fabric. I'm going to be looking at, Azure Databricks and how they're all built with just a standard recipe, which is really sensible. But in actual fact, it was talking about the consolidation of things like hyper automation and RPA and digital process automation, which is based on people driving the actual patterns, to traditional operations orchestration tools in your IT operations landscape, to test automation tools where, we're all starting to do automation, whether it be business process automation, whether it be traditional RPA. It's automation, and so as you start automating, the more you can automate the planet, the easier your repetitive tasks are kind of reduced. So, embracing automation, I guess, is one of those steps towards testing. But then I think you've also got this diminishing returns, which is, I go to customers and they say, we've got 10,000 automation scripts. And I say, okay, why haven't you got 20,000 scripts? And they kind of go, well, 20,000 is just too much. And you kind of go, well, what's 10,000? What's the coverage of those 10,000 scripts? And I think that's the problem. We're starting to build estates of more and more automation, but then we're having less and less confidence in the automation that's running. So you've got these huge, glorious regression packs, which require people to fix them and maintain them and refactor them so many times that you're not sure whether or not it actually is passing against the requirement. because the requirements traceability is long gone, because, we just don't have that link anymore. And people are changing, sprint from sprint a requirement. And of course, that's not reflected to the user behavior in those tests, because they're kind of inherited from maybe the last sprint or the sprint behind. So we're starting to see this automation creep where it's just exploding. And then it's kind of, I'm literally overlaying that for some customers. I did it with a large German automobile company based out of Munich. And I took all of their automation regression, all of their, functional and non-functional stuff, and security and crowd testing and exploratory testing, mapped it over the actual functionality of the application estates. And you realize actually the coverage is incredibly low. That you mentioned the word happy path. I tried to ban all happy path, but what I was trying to mean is not just happy path for E2E and contract testing and, people creating payloads for APIs that they know work and not have every single type of, account and, country or whatever else you need in there. Is actually, it's as important to have test data coverage as it is to have test coverage. Like you mentioned, it's that kind of, yes, I'm going through the happy path, but I'm trying it with all permutations of different types of accounts with different statuses. But actually now I'm moving away from those happy paths to really explore some of those edge cases. And that's where things like model-based testing really help and really kind of allow you to understand, well, actually, I've only got 20% coverage of my app with these 10,000 scripts that I'm running. So, definitely moving towards more model-based testing and digital twin testing is another way of getting more confidence around how your app is performing.
In this conversation about automation, that's another term where it can be very overloaded or misinterpreted. And I'm wondering if you can talk to some of the ways that automation manifests and how it might be disjoint from what a lot of people think about when they say automation, where they're saying it's in my CI/CD pipeline, it's automated. What are some of the other aspects of automation or the capabilities that are being sought in this process of automating that are, not already covered by the ways that your typical software development team is approaching their overall lifecycle?
Yeah, definitely. So, I do blame occasionally Lisa Crispin and everyone else who kind of always throws the triangle of death of UI being at the top, very brittle automation, and then API, and then component. We have this kind of viewpoint that, that should be the proportions. And it's like everything is that actually it depends, right? It depends on how you guys work, the quality of the software engineer, to how much testing needs to be done. But, I guess that word resilience kind of comes in there in saying, well, how do you do more than just your standard tests? You could use diffblue to auto-generate your components test, right? That's going to prove something. Well, it's going to prove probably only your Java libraries for people using Java, right? But, part of it is when you kind of go into, well, where are the other phases where we can start leveraging, doing better testing? I mentioned things like service virtualization and network virtualization and this kind of concept around digital twins. At Keysight, as we're probably more famously known as a hardware company, right? We're a hardware testing company, which started off with Hewlett-Packard back in the garage in 1938. And Dave and Bill were both, sat there doing build and test. Everything was build and test, iteration 1, iteration 2. And they were building these machines for Disney, and they'd get feedback from the customer saying, they wanted this additional feature or whatever else was needed. And then they would add it and they'd do Mark 1, Mark 2, Mark 3. And then, of course, Keysight kind of came into this area of, well, yeah, we can, use our test equipment to emulate this, right? Or simulate this kind of, in this case, I'm going to give the example of a 6G wave, right? Which one of our labs did the other day. Now, of course, we know 6G is not here, and we know it's not going to be here probably for another 4 years. The definition's probably at least another year away. But we can test a 6G wave because we can deal with their frequency. We can measure it on a device. And like you kind of pointed out earlier on, we're quite used to the hardware abstraction layer, which is, well, we're just going to, virtualize it to nth of degree and not care about, things. We'll put it into a container and we'll believe infinitely scalable because we're going to do some kind of heat-based load balancing profile in production. That's great. But, you're just adding more complexity to it without understanding that and expecting the the fact that you're building into a cloud, that you add that ability to cover from any kind of systemic failure or issue that you've got by spinning up more pods or whatever it may be. And it's kind of got us quite lazy in the sense of, we've kind of not really relied on writing code that's not going to give us huge amounts of memory leaks in production every 15 minutes and garbage collection running on the compute nodes. We kind of getting into this kind of, ability that we can understand what's going wrong and how we can actually prevent it. But they're all a whole separate set of new tools, right? These tools aren't the same as what, were there before. So I give a bit of an example with the 6G, right? We've got a bit of a demo that I did the other day where we've got a mobile device. It's launching something, I don't know, let's call it speed test. We've got the spectral analysis tool, which is showing that it's pulling the network coming from the beacon, wherever that might be. We're seeing the battery drain of the instrumentation from the actual device. We're seeing how the different GPUs are running and the cores and the CPUs are performing on that device. And then we've got, other different instrumentation that we can look at and create that and then emulate it. So I was talking to our guy earlier on today about, well, I want to put more, I want to lock more memory up in the device. Okay, well, we'll increase the device. And it sounds like, well, yeah, it's a mobile device, right? It's, who cares kind of thing. But, we've having the same conversation with people like Meta and Microsoft at the moment around, mixed reality for the Google Glasses V2 and the Apple Glasses. And, that kind of a state that we're going to start seeing of the app again of apps being moving across for that. And then you've got things like, of course, Meta's already got things like the Oculus for doing VR and that environment. And we're doing high speed, 120 frames per second at 4K per eye. We're doing full computer vision and OCR to see if there's any lagging in there. We're pulling all the metrics off the actual device. Again, we're understanding if it's been affected by interference or anything else. Being over a wire, we're emulating the 5G versus a 2.5G network connectivity, the last mile, the packet loss, the jitter on the line, where the let's call it CDM, but the edge meta is for the location in. And now you need a Cisco's, every single Cisco qualification to even understand the landscape of how, that information's getting there. How can we understand that or even build for these next generation, platforms? And, my guys who are, the R&D guys are all looking at things like the quantum computing kind of use cases as well. You're thinking, it takes me, I'd have to read a book, probably what the teaching quantum physics to your dog book to actually even understand how that works in the first place. But we know there's use cases for it, so we're developing them. And I think that's the problem is we kind of, we abstract things to the point where we're like, well, it doesn't really matter. My first day, we launched the autonomous radar emulator, which allows you to emulate animals flying across the road or, 100 people, and being able to use, car to X, infrastructure to X techniques to be able to test, computer vision to say whether it should brake, the IVI systems in the car works. How do you even start testing this stuff? And it's all done at the component level, right? And that's the problem is when it comes together and it becomes a Tesla, testing that digital twin is incredibly complex. And it's out in the wild. And if it's in the wild, then, potentially you're going to end up on social, social media at some point in time, like the HBO example is, we know they're doing their best job. And we could probably bet, if we were betting people, that they don't actually own their streaming service like Netflix doesn't. They're probably using Amazon, streaming capabilities. So why are they to blame for, people not being able to access the system? The same as, Apple, we always see Apple in the news, but Apple don't have their own cloud system. They use other people's cloud stuff. And it's that kind of thing where we're building on other people's, systems and we're expecting those 5 nines to protect us from, catastrophic failure and embarrassment, which could potentially wipe out a software product. We've seen it in the past. And I think we're going to see this even more when we start going into the metaverse and beyond. And of course, that's just starting to get into crazy land, right?
Absolutely. And the other interesting aspect of using automation to verify the quality of your software is that it's just more software. So it gets into the problem of who watches the watchers. Like, how many layers do you need before you can say, okay, this has gone far enough. I'm just going to throw up my hands and say, I don't know for sure. I'm pretty sure it's going to work. Let's just push the button and see what happens, kind of a thing. I'm wondering if you can maybe talk to some of the ways that teams who are looking into investing in automation to help with their quality assurance process need to be thinking about what are the capabilities that they need to look at? What are the ways that they need to do their own due diligence to understand, is this tool actually going to tell me what I think it's telling me? How do I know that it's doing the things that I tell it to do properly and that it's giving me the answers that I need to, build that confidence? Some of those questions of kind of the meta problem of quality.
As a slightly, which won't be a use case which people are in there, but exactly the same thing. I was talking to the guys at Meta the other day, and they were saying, how do we know that the inputs that you're doing for the headset are a valid movement based on my body structure, right? So we're connecting Connects to look at body movement. We're making sure that the numbers that we put in could physically happen on a human, right? That they could move their head and the gyro could go at that kind of speed. You're in a confined amount of configuration parameters, and I think that's where you've got to start. Is you've got to kind of understand where to put all your eggs, not in one basket of just doing API testing and use Postman and just get something in there and then start mocking some stuff out. And you've got baby steps towards okay, I'm feeling more confident now, I'm going to scale up and maybe start injecting large amounts of payloads into my API tests. And you keep on maturing your automation techniques. But as you're going through that, you're investing more and more time. And as you said, there's this kind of water effect of, well, how do I know that that's good? How do I know that those payloads aren't just completely handcrafted and that actually once it goes into the real world, that it's just going to not just explode? How am I going to be able to simulate, failure to see how it recovers? And I think, little and often is kind of the way to do it, is not to invest too much, if any, stack. It makes it, even I feel that it's a hard way thing. I used to, when I started in the 90s, I used to talk about manumation, doing manual effort to create automation artifacts. And that was in the glory days of record replay, right? And I think this is the problem, is if it's too good to be true, it probably is too good to be true. And use a lot of hype, especially with any vendor or any tool or testing product that says, oh, it's just going to do everything for you. And we know that's not the case, right? And people sometimes need to be able to look under the hood and see what it is actually doing. It's what assertions it's doing, and be also familiar with it in the language they trust, right? So if you're writing it in Python, of course, you want to be able to probably execute your tests within Python, which, Selenium, of course, is a great place to start, in the sense of it's a W3C standard, for web-based testing. So, use open source as much as you can until you need to scale. And then when you need to scale, you need to start thinking about investing in tools that are enterprise grade. So that would be my kind of, tip.
To the point of trusting the results that you get from the tool that you're using, there is also what you were saying about understanding what are its capabilities and its limitations, so that okay, this is the tool, this is what it can do, so these are the areas where I'm going to apply it. But this piece is actually outside of its range of capabilities, so I need to think about a different approach. And I'm wondering, what are some of the useful kind of practices or strategies for teams to understand what are the maybe core workflows that they need to target, and some of the ways that they can start onboarding automation into their quality assurance process, and how to kind of manage that overall life cycle? Because it's very easy to say, okay, I'll go buy the tool, or I'll use the open source project, I'll do this thing, and okay, great, everything's doing what I want to. And then it just becomes another piece of tech debt because you don't maintain it. And just how to think about the overall investment process of saying, okay, these are the core workflows. I need to make sure that these work all the time. I can be confident that the tool is going to give me the outputs that I need to have that confidence. And how do you know sort of when you've been taking it too far where it becomes unmaintainable, and like figuring out what those boundaries are, and how to understand the overall costs and trade-offs of that process?
Again, it's an infinite dilemma, which I think everyone's got, is, even with the idea of starting small, but thinking big, in the sense of, okay, I know that some of this is throwaway and it's just going to get me going in the short term, but I need a long-term strategy of, well, how do I keep this maintainable and scalable? And it's with everything, it's the same, in the sense of, even with Agile, it's, it works well in pockets of the organization and DevOps principles, but then may not work as well in other places. Is getting an enterprise level automation strategy might be near impossible. So, there is teams going to be going off and doing their own thing, and there's nothing wrong with that. But, kind of where I was leading into with the W3C, or using standardized frameworks as the baseline and industry standards, kind of allows you to at least ensure what you're investing in makes sense for the long term, but also using blueprints that make things as reusable and lightweight as possible. And of course, we've talked about things like BDD and Gherkin and SpecFlow, or some other type of application to do that. And again, you have to get investing in that maintenance, in keeping those tests relevant. That's where I think, sometimes moving to things that are going to be more intuitive and also self-healing and being able to actually maintain itself. Of course, I said as a disclaimer earlier on, of course, it's not magic. It's going to, using AI for testing. So book, which I've just done is artificial intelligence in software testing. And I sit on the ISO committee for the 29119 part 11 on artificial intelligence for software testing blueprints. There is proven methodologies that we've used over the last 4 decades to self-heal things like your domain object model, which is usually quite not very robust, automatically generate API tests from Swagger specs, or, be able to using auto generation capabilities to make it a lot easier to maintain. And of course, we're very visual human beings. So yes, the tendency is to script it, but, in actual fact, you want to also be able to visualize that and collaborate on that with other people. So you want to be able to understand, well, what's in the estate, what bits have been automated, which bits haven't been. So this kind of approach to model-based testing really helps, because modeling, again, is that natural language we kind of started this conversation off with, was, if you're able to kind of express it, and we have something called SenseTalk, which is an English-based language from an NLP perspective, you can write simple statements, a bit like, not as powerful as Python, of course, but, to that kind of, here's some standard functionalities which call things like Google Computer Vision. So if you're not familiar with OpenCV or, some type of OCR engine, you can just call that feature and then use a tool that enables you to train it or optimize it. So you've got those capabilities instead of having to build them yourself. Now, we know we could grab TESLFO or something else and, start building something ourselves. But why build it when you can just consume those services, whether it be computer vision or some kind of, test data management, TDM kind of engine that can generate you synthetic data. You're much easier to utilize these. And this is where I said the off the shelf kind of viewpoint is that once you get to a certain point, a bit like Postman, you need to pay for a subscription so you can all collaborate together and start doing more scale and run more tests and, create more insertions and create more mocks, or do what you need to give you more confidence. And I think that's the big thing to be aware of, is you need to at some point spend some money and dip your toe into some of those additional functions that are going to really accelerate your time, your quality engineering efforts, without having to, spend huge amounts of time maintaining your scripts as you would have to do maybe potentially your code base. And also, who else in your team can be involved with that, whether that be a traditional software developer in test, or it could be a technical test, or even a non-technical tester. And of course, that's the dream, is that everyone can collaborate and build these. The reality is there's always a certain level of code that needs to be written. And things like SenseTalk definitely drop the barrier of entry, because it's kind of language agnostic in a way. Everything's very basic. And that's why in the early days, people were using things like TSL, test script language, and then things like Visual Basic, which was very unfortunate to actually write. They were simple languages, but you can build everything on Python. You can build everything with SenseTalk as well, which can be wrapped in Python. So, I'd recommend balance it and work out when not to spend loads of time building your own framework, and when to, spend time actually thinking more of the logic and the DSL that you needed to define.
In this overall space of automation, particularly as you start getting into more AI and ML powered systems, what are some of the limitations that people need to be aware of? What is the kind of upper bound of what people can expect from automation? Because when you start throwing around the terms AI and ML, it just starts to sound like magic. And you say, oh, I just pay for that and it'll do everything I want. And, I don't have to worry about it. So what are some of the kind of natural limits that people can expect as they start to dig more into some of these, advanced systems where they are using more sophisticated processes?
Yeah, well, you've just got to think about it in the same way that you would apply ML with your own projects, right? They've got to be explainable AI, right? You need to understand the use cases because they're very narrow, as we know within the landscape. And something very simple like self-healing a domain object model reference of an XPath or a regular expression has been around for years. So, what's revolutionary about, what's coming out at the moment? Of course, computer vision helps. Computer vision, one of my guys, Carl, this morning did a bit of a demo with Meta, where we're identifying things in that environment. So, yeah, there's a door over there or something's happening over here. Yeah, that's pretty simple. My friend created a company called GameDriver.io, which does all that with Unity, right? It knows the Unity libraries, it knows what it's building. So when it sees a person stood in a game, it understands how it should look versus the reference libraries, right? There's a lot of stuff that sounds like, well, brilliant, it can do this kind of stuff. But what are those AI use cases that actually, are going to help me? I tried to do a demo yesterday with someone showing them our bug hunting algorithm. And, it's like, well, what it does is it understands where within a system it finds an issue. And then there was always this rule that wherever there's a defect, there's typically another defect behind it. So, part of it is if it looks at it and yes, let's think it's just React or Flutter or whatever else it is, if it sees that, it's in Salesforce and it's dropping down a box which doesn't allow you to change the location to New Zealand, there's a good likelihood in another area which you can edit your address details, it's also going to fail, right? So it starts identifying the meta domain language behind that to say, well, yeah, I understand that potentially anywhere else which has got a sign up or a registration might also feature this, which might also reference it. You could look where the databases, are also being accessed from a select statement, right? That's really quite basic, but it's doing bug hunting. So it is going around trying to focus based on weights where it should spend most of its time generating more tests to be more rigorous, i.e. go through every single one of those permutations of languages. The same thing goes for our exploratory testing stuff. It is very rudimental in the sense of it uses computer vision to recognize what's on the screen, and it understands within that one page, there's a menu section. If I go to that menu and return back to that menu, of course, with any deep learning system that's been reward based, it's going to go, okay, I'm here. So it creates the model. It knows where it is. It's back at the menu. Now it knows the steps it needs to do to recreate to that point of time before. So then you literally just say, I want to be at this stage where I'm just about to process an invoice, get me to that state. And the system will be able to get to there because it understands what it's looking for and how it's done it before in the past. So there's a lot of, simple applications. Tomorrow I'm doing with my friend, Dr. Tarek King, who's from test.ai, who's published a lot of machine stuff around AI. And the last 2 books that I've done, he's featured in, he talks about these standard use cases. And, we've all, talked about things like, oh, well, log in turns into log on. And how do I understand? Well, yeah, we've seen fuzzing from, AWS for years where it can kind of understand there's an email and password box. It then gets the understanding that it needs to register first, needs to activate an email and then come back in and actually do it or get a 2-factor authentication code to progress or have certain site permissions. So part of it is these systems are getting better and we are learning and it is becoming smarter. Is it going to replace a human anytime soon? Absolutely not. But does it save you time? Absolutely. Can it auto-discover things and, understand structures of an application quite easily? Yes. Is there much work to do to make it even bigger and better? Absolutely. And that's where which is why we're investing so much in AI-driven testing at the moment, is to try and define even more use cases that we can use.
In terms of your experience of working in this space and watching the ways that software teams and QA teams are trying to get their hands around this infinite complexity of software systems and validation and ensuring that the projects that you're working on are doing the things that you are hoping that they're doing and that they're supposed to be doing, what are some of the most interesting or innovative or unexpected ways that you have seen automation applied to that question of quality assurance?
Yeah, probably lots of crazy things that I've seen people use automation for. And I think this blurs the boundaries between, automation and RPA, which the similarities are very similar. I remember myself using an automation tool to board loans for Lehman Brothers just before it fell, and actually using the automation engine to be able to go from a mainframe system to take that information and do some basic, well, it says flat in this system and it means apartment in this system, and then be very flexible and have this, I'm going to use the word cognitive recognition, but not nowhere as advanced, where it can at least understand two different systems. And that could be, your SAP to your SAP HANA migrations. It's getting to that point of, when do we start using robotic process automation and traditional automation and operations orchestration together? And, I've seen a lot of people using things like process mining, using process mining tools to understand what users are doing, to then be able to try and replicate it. Whether, I've seen it done for Brexit, where they use how people are behaving at the moment, and then they model what it would look like with a no deal situation versus a deal situation. And then they build the system based on what those models look like. And I think we're starting to see lots of ways of maybe modeling things before they exist. And I threw out about 10, 15 years ago at Gartner this idea of lifecycle virtualization, which was, could you virtualize everything, even the system, without even having any code? Could you model what that would look like before you decide to build it, and then work out whether or not that's a good idea? And I think we're getting to that point now where we can understand, if you do this, it's going to break this part of the system. Or if you do this, there's going to be a higher risk level in the kind of the risk-based testing kind of methodologies, looking at impact analysis, looking at how you can pull all this information together and all this observability together to make better decisions and more informed decisions of how long is it going to take to test. This idea of everything can fit into 2 weeks, and, within those 2 weeks, something of value can get delivered. Is there always going to be the same amount of automation work done? Is there always going to be the same amount of testing work? Well, it depends. It depends on this, I always mispronounce psychometric complexity, but, it's the complexity of the code base, how much tech debt, as you mentioned, is in there, and how old the code base is, how many lines of code it is. I think we take everything as a standard blueprint of the best scenario, and then we go at it with best intentions. And then we find that we're in a bit of a position where people are making decisions, maybe blindly, whether or not something's good or it's not good or it's ready to go. I think we now need to get to this point where we're starting to build in the quality into the systems with the idea that it will fail. And the question is whether or not it fails gracefully. And, I think this is the new reality, is that testing is moving further down the life cycle again, because we just don't have enough time for anything. So test everywhere, test often, and deploy even more often, and then learn from what's going on. And I still think we're missing those tools, which, those ops tools that ops have had for such a long time, like network traffic and gateway utilization and everything else. People don't have access to those same large scale operational tools that give you all this great insight about, how the system's actually working in the real world. We're kind of still very much, not blurring the boundaries of dev and ops. We're building, infrastructure teams and, everything else into a single team, and then generating more silos. And, I think, we need to at least think about the patterns that we're going to build in the future. And I am confident that they're going to change, and people will start doing things, a lot of more center of enablement, not the center of excellence days of building teams that are automation skilled, and equally not expecting everyone to be a jack of all trade, master of none. I think we're going to start seeing some really smart models of how we do distributed development at scale, using augmented intelligence from lots of people in lots of different areas, and not just in, you have a developer, 2 testers, and a project manager in a team. Things have got to be more flexible and adaptive. I think we're moving into this new world where we have to do that, and we have to rely as a service on other people, whether it be computer vision, retail as a service for algorithms of looking at people's t-shirts in, adaptive marketing or whatever else it may be. It's starting to be consumer driven in these incredibly complex ecosystems. And we're also going to need to start offering people visibility into those environments. So if you build with HBO's gateway, you need access to all their debugging information. So because it's an endpoint which that you rely within your organization, you can't just consume something and blindly have no idea how it's performing, how reliable it is, how resilient it is. even access to the code base. You're never going to get that. Whereas now I think we're going to start seeing that bit of, I'm picking this service over this service because of its track history, not just down detector and guessing that they build it on something else, right? So, I think we're going to start seeing really smart solutions in the future, and we're going to be the ones responsible for building resilience in to get us to that grade where we're getting an A grade or a B grade or a C grade of must try harder kind of thing, or must spend more time building more resilience in. And here's where you're failing: it's security, or it's process, or whatever it may be, or pipeline. Your pipeline's not very good. Whatever it is, I think we're going to start having to look at those dimensions of quality and be scored by them.
Yeah, I think that your comment about the visibility into the systems that you're relying on is very key, and definitely one of the prime motivations for why open source has become as ubiquitous as it is because everybody needs to be able to look under the covers and understand what's actually happening. And I think that, to your point, for some of these commercial products, there is starting to be more of a kind of two-way street of understanding, okay, I'm trusting you to do this thing. I need you to give me a feed of information back so that I can make sure that my assumptions are actually correct. Or, when those assumptions aren't holding true, I can figure out why, kind of a thing.
Yeah, and I think, we see it with bleeding edge technology like smart city as an experiment, right? Is these countries sharing their large data sets of how they've badly adopted, a smart city system like Dubai. And then they use that historical information, whether it be information they've observed, and they allow people to run their own scenarios against what those failed systems are. Maybe that's where we're going next, is you're going actually to Netflix and saying, yes, there's all this great chaos engineering and, you're delivering 26 times a day into production or 26 times a second into production. But, here's the blueprint of how it actually works from a design methodology. And we'll share that so we can run our own models of, well, we're not just blindly going to use Spotify because we also like listening to their music and Squad sounds cool. We'll actually say this fits this methodology, and these architectural blueprints fit my kind of organization and my risk profile and what I'm expecting from my customer. And, these systems that people are building for, critical infrastructure systems are going to have a different risk profile to people who are wanting to bring out gaming platforms. And I think this is what we need to start doing, is we need to start maybe sharing from an industry perspective, like we have been with open source. What else can we share? What kind of historical data can we do? And that's why when they said automation fabric, I was hoping that that's what was going to be. We start seeing people being able to share a lot more information and learnings about what they do. And, I should have access to Atlassian's platforms to build and extend and adopt how I do it. But I also want to know what everybody else is doing and how they're having successes or learning from failures, right? And that's the $1,000, question is, celebrating those failures and, but learning from them. They shouldn't just be somebody tweeting that they're not happy because a weird edge case has happened. It should actually be more of, okay, what can we learn from this? And now we've done our investigation. What can we share? What can we share with the creators of Kafka? And what can we share with the community to kind of learn from these blueprints? And in the app ops kind of mentality of how do we build stuff that's going to be easier and not try and reinvent the wheel every time we do it? Because we've got this kind of this self-desire to want to learn new things and try and build new things. Has all the code that ever needs to be written been written? These kind of big questions that I'm not saying are right or not right. I think it's more of, if we're going to evolve, how do we evolve software development and take it to the next level? And what does that look like in the same way people start talking about Web3 and decentralized internet? Okay, well, what does that mean for us? What does our industry need to do? How do we work together and build more things like open telemetry and maybe even open testing? So we're all, sending flags to each other saying, I'm going to send you even in production, a payload, which I want you to accept, but actually it's a dummy response. Instead of my favorite thing with eBay and Amazon is when people post listings that say, do not buy, because there's no sandbox environment and they literally are hitting the API in the way that I'm sure open banking is as well. So, there's so much more we need to mature. And I think engineering, which is where we started, is adding engineering back into things and being able to push back and say, no, this isn't t-shirt sized XXXXL. This is just an infinite probability engine, which we need to build, and it's going to take 442 years, and we need to go to the crowd to bring in hundreds of engineers like Kaggle would do for a Python equivalent of getting people to start collaborating on an incredibly difficult problem, be rewarded maybe even financially to, solve problems that, you can't expect just your one ML, data scientist guy to solve. You've got to start looking at the world as a kind of a smart, kind of scalable solution like Amazon Turk, but scaled up to the next level.
In terms of your experience of working in this space and working with teams who are trying to understand and address these challenges, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
Well, personally, there's way too many. I think we all have probably too much access to too much systems, right? It's kind of one of those things that maybe we don't need access to certain things or certain systems, but we also don't know how those systems are always connected. We joke about HBO going down, but we don't know if that was just someone running some stress or load or spike testing, and they pointed it to the wrong environment and they hit production. Right? There was some debugging mode that was still turned on that caused some pointing to the wrong structure of a test string within their schema. We just don't know, right? And I think that's the problem, is we don't know what we don't know, and we just assume that this is, going to work. And, I've had times before where people have said to me, it's fine, you can hit this node as hard as you want. And I've hit it and then come back and said, oh, by the way, that shared a cluster with some production systems, but we didn't realize you were going to hit the network so hard and bring the network down, and DOS attack the entire thing. This is the thing, is with great power comes great responsibility. And, the guy who, brought down PlayStation for the same price for compute time as, his monthly subscription, because you got this power at your fingertips. I've made those mistakes. We're all human. I think we've got to celebrate those, bring those to light as well, not cover them up. The days of, hacking it, going in and just ninjaing stuff in production, those days are over. Now we need to be confident enough to be able to not just rely on we used to have a team which we used to refer to whoever's on call as Superman. So that Superman or Superwoman would have to, jump in at the last minute, read somebody else's code base, get a fix in, as soon as possible. We can't expect that from everyone. We can't be based on a superhero culture as much as we are at the moment. What happens if those three people which in your organization are holding it all up disappear? We can't expect the organization not to continue. And so therefore we have to do, which we're programmed not to do, is to build our single point of failure out of everything we're doing and allow people to have that visibility, clear documentation that makes us interchangeable. And I have seen organizations, very few, usually Danish or something like that, who literally they turn around and, I come into an organization, they go, oh, we've wiped out 4 of our dev guys. They're just, all off ill. We're losing them this week. And there would be no drama. It'd be like, oh, it's fine. We've got a flex team. We've got people who've already been, code reviewing them. They'll pick up the workflows. They'll pick the tasks up. They'll continue. We'll have the same velocity, which we already estimated because we had already factored this in based on learning over 3 years how our team works. That they literally had this kind of, Microsoft did it for a small period of time while I was there, where it's literally, they're to the point where people aren't stressed and worried about, well, what happens if, I can't get this out, or, the cutting corners, that pressure disappears. And, so does that kind of single point of failure of superstars. And, let's move into that kind of, well, we're here and we're doing, some, think of it as a more for Mr. Robot, you're just kind of coming in to autonomous and anonymous and just doing a bit of work with hundreds of other people who are also contributing to that. And if you're not there, it's fine. They're still going to get the end result. And, that's how we need to start working in kind of swarms of people that, if the hive is a problem and the queen ends up having to be replaced, then, there is no dramas, there's no stress, there's no politics or, who's got access to all these secrets. Literally it's no stress development. And then maybe we've just invented something completely new, which is going to be great for neurodiversity everywhere, is people are just going to be sat there going, I don't suffer from these problems anymore because actually my environment, which I'm working in, is just like a delight every time I come into work. Just think of that.
And for people who are interested in understanding more about the capabilities of automation, how to think about applying automation to their software quality problems, what are some of the resources that you recommend for people who want to dig deeper?
Loads out there, loads of great podcasts as well. I do the QAlead.com. I'd recommend Test Guild with Joe Colantonio, who do a performance and automation guild. I sit as the president of the Vivek community, which is the largest independent software community, about 80,000 users in over 100 countries. And, again, you can go on there and there's loads of resources for free, loads of people to talk to and have those peer conversations in a community area. It's a non-for-profit that's run. Always just reach out to peers, right? I've got the easiest connection. It's linkedin.com/in/automation. So, I can always point and share you resources of courses that you can do that are all free and can get you started on your kind of automation awesomeness journey. The community's there and wanted to support. There's so many good events that are running up. I was chatting the other day that they're running an Automation Star event. I'm in Star West in LA next month. And, there's so many good events that are out in the calendar. Go to test events. There was always a stigma of, should developers and testers all be, going to these kind of events? But, we're doing KubeCon a week after we're doing Star West. Part of it is, I think, the development community and the test community are sharing events a lot more now. And, when I was in Australia, there was an event called Fusion, and it had project managers, developers and testers all in the same streams and stuff. And I think that's what we've got to do, is we've got to start getting those events where we can all share knowledge together in the software kind of challenges as a whole, really.
Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And with that, I'll move us into the picks. This week, I'm going to choose The Sandman, particularly because I just started watching the Netflix series that just came out, but also the graphic novels, which are the source material by Neil Gaiman, who's one of my favorite authors. So definitely recommend looking at everything he's done. So with that, I'll pass it to you, Jonathan. Do you have any picks this week?
Of course, I could have easily gone for the game of quality in game with the new House of Dragon, and which we've already mentioned, which was very good. I am very excited about it, and I will get round to going through the books at the same pace, I think, as I did last time, or reread them, as the case may be. I'm going to kind of throw a bit of an odd one out for everyone and go with Mystic Quest. I know it's already had so many seasons. It's quite, the last one they did was during the COVID lockdown. And it's also on Apple TV, which is obviously a bit of a pain. But, if you haven't seen Mystic Quest and maybe not seen, It's Always Sunshine in Philadelphia, it's worth checking out. It's about a game development company. And it talks a lot about, there's testers in there. There's some great series as where the two testing ladies are always throwing kind of bugs into the problem. You've got people like Snoop Dogg doing stuff. There's some in the metaverse. It's, fairly up to date, but it gives you an idea of software development and how that, it becomes an interesting storyline as well. And of course, there's lots more. I'm not going to give you any spoilers. So if you haven't checked it out, Mystic Quest is, my pick of the time.
All right. Well, thank you very much for taking the time today to join me and share your experiences and insights on the ways that automation can help alleviate some of the pain of quality assurance and remove some of the load on people doing the work. So I appreciate all of the time and energy that you're putting into that. And I hope you enjoy the rest of your day.
Thanks so much. And make sure you subscribe.
Thank you for listening. Don't forget to check out our other shows, the Data Engineering Podcast, which covers the latest on modern data management, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you learned something or tried out a project from the show, then tell us about it. Email hosts@pythonpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.